Hi, this is COMP1010 at the University of Manitoba. I'm Dr. Celine Latulip, and today I'm going to be talking to you about data types and converting between floats and ints. So we want to understand the different results of operations and make sure that when we're having an operation done, that we are storing it into an appropriate data type. So we've already talked about how for the standard mathematical operators, if both numbers on the sides of the operators are integers, then the result will be an integer. But what happens if we have a number on one side of the operator that's an integer and a number on one side that's a float? Or what happens if we have a number on one side that's a long and a number on the other side that's a double, for example, right? And there are a number of different number types, so we need to understand what's going to happen. And the way to think about this is that the result type is always going to be the biggest of the two types. And when we mean biggest, we're not talking here about the size of the number, but we're talking here to representation and not how much storage it takes up in memory. So biggest, the order is doubles are the biggest, floats are the next biggest, longs are the next biggest, and ints are the smallest of the ones that we're going to use in class. So an int is a small number, and we can store an int in a long. We can store a long in a float. We can store ints and longs inside floats. And we can store ints, longs, and floats inside doubles because that's the biggest type. So you want to sort of visually think about it this way. You can always store something smaller inside of a bigger box. And this is not, again, representing memory space, because actually ints and floats take up the same space and longs and doubles take up the same space, but just in terms of representation. You can put an int and it will automatically get converted into a long if you try to store it in a long. You can put a long into a float. It'll automatically get converted into a float and store in here. And you can put any of these things into a double. It will automatically convert into a double and it'll be stored in the double variable. So if we have 5.0, which is a float, plus 3, which is an integer, that is going to do the addition. We're going to get 8. It's going to be a float, though, because float is bigger than int. Okay. If we have 5.0d, which means this is a double, this is the really big type, and we add 3, an int, well, double is bigger than an int. The result is going to be a double. Okay, so the result type of these operations will always be of the type of the biggest of the two different numbers. If we have 5 plus 3, they're both ints, and the result is going to be 8, and it's going to be an int type. If we have 5L, which is long, and 3.0, which is a float, the result is going to be 8, and it's going to be a float because, again, we're going to use the bigger type. So you just have to always remember that we're going to have the biggest type be the result when we do an operation with numbers of two different types. So you can get errors because of bad operations. If you do a division by 0, that will cause an error because mathematically that's undefined. So that's what this looks like. So over here we do a print ln of 20 divided by 0, and processing gives us an arithmetic exception, divide by 0. So you can't do that. If you have overflow, you can also get strange results. And what we mean by overflow is, say you have two ints and you multiply them together and they make such a big number that the result doesn't actually fit inside of an int. That's what we call overflow. And so if you were to try this and you multiply 123,456 by 123,456, that's going to generate a really big number. And if we look over here and we do this in processing, you'll see that the result we get is a negative number. So it has generated something that are a bunch of ones and zeros, and in the int data type, that representation of ones and zeros actually maps to a negative number within the range of integers. And so this is an unexpected result. So you have to be careful with overflow. So if you think that you're going to be dealing with quite big numbers, you probably want to stay away from ints and go with something like longs. All right. So processing works a step at a time following order of operations. So if we have this example of a set of operations we're going to do, and we're going to set this to a float result, we have 1.0 plus 1 divided by 2 times 3.0. Well, the first thing we're going to do order of operations wise is we're going to go left to right and do the highest order operation, which is the division. And this is 1 divided by 2. This is an integer divided by an integer, so we're going to do integer division. And 1 divided by 2 in integer division gives us 0, not 0.5. Okay. And then we're going to take that 0 and we're going to do this next operation, which is the multiplication. So 0.3 or 0 times 3.0. This is an int times a float. So this is going to do float multiplication and give us a float result. It's going to give us 0.0. And then we're going to have 0.0 plus 1.0. So this is going to be a float plus a float. We're going to do float addition, and it's going to give us 1.0. So in terms of the order of operations, we're doing integer division, and then we're doing float multiplication because one of these is a float, and then we're doing float addition because both of these are floats. And that will end up giving us a float result. So you want to sort of follow carefully and understand the order of operations, and also for each operation, what type the result will be. We of course want to be careful mixing up integers and floats. So we can't have integers store floats because integers are a small type and floats are a big type. So we can't put a float into an int. We can force it, and we'll see how to do that later with casting, but you can't just do it automatically. So if you type something like this, int result equals 2 divided by 3.0, this is a float, this is an integer, it's going to do float division, it's going to give a float as a result, and it can't store a float in result because result is of type int. So if you type this in processing, you'll see that you get this type mismatch. Float does not match with int. So it's saying the result of this is a float, and you're trying to put it into this, which is an int. And you can't do this sort of indirectly either. So in this case, what we're doing is we're creating a float variable, a. We're putting 2.0 in it, and then we're using that in this operation here, a divided by 2. So a gets replaced with a 2.0, so we have 2.0 divided by 2. Again, we're doing floating division, and the result will be a float, and so we can't store it in b because b is an int type. So you can fix this by making the thing that you're putting the result into a float. So in this case here, we've done the same thing, except we've made it a float. Float result equals 2 divided by 3.0. This is fine. Down here, when we print result, we see that we get 0.6667 because result is a float type and it can store fractional numbers. Here we've got the same indirection. We've got a as a float being set to 2.0, and then we use that in here. So 2.0 divided by 2, and the result of this float division gets put into b. And so here we see that b gets the value 1.0. So you also want to pay attention to this in terms of the assignment and what's compatible, because you can move from the smaller sizes to the bigger sizes. So numbers that are of these smaller sizes will automatically get converted into bigger versions and stored in these variables if they are of these types. So let's look at an example. So say we have an int called int value, a double called double value, and a float called float value. And we take int value and we try to assign the literal 57.3, which is a float, to it. This will give an error. It won't work because we're trying to take this and fit it into this small thing. If we have a double value and we assign it 57, which is an int literal, well, an int is small, so it can be converted into a double type easily and stored in a double. This is what we call a widening conversion, and that's okay. It can happen automatically. Here we have float value getting assigned double value. So we're taking something that is double and we're trying to assign it to something that is float, and this will give us an arrow. This is a narrowing conversion, and it can't be done automatically. It can only be done with casting. But if we do it the other way around, if we have a float value and we try to put it into a double value, that's okay. We can take a float, automatically convert it to a double, and store it in a double, and that's not a problem. So the narrowing conversions, when we're going from big to small, will not be done automatically for you. And you have to pay attention to the literal types that you're using and make sure that you're using the right type of literal when you're putting them in. So these things come into play when you're using functions, especially the functions with parameters. So every function has some types of data that it needs if it has parameters, and a type of data that it gives back unless it's a void function that doesn't return anything. And we'll talk more about functions later, but typically when you look at documentation, you'll see a template or a signature that looks like this. It says, here's the return type, here's the name of the function, and here are the parameters. And it's just saying the first parameter has to be of an int, the second parameter has to be a double, the third parameter has to be a long. So the result type and the parameter types that are used. So you have to give it the correct number of parameters and the correct type of parameters. And it's okay to assign compatible types. So we can do a smaller type for the parameters, but not a bigger one. So let's look at what this could look like. The above could be called in program like this. We could create a float variable to store the result, call it answer, and then we call the function, no such function, and then we send in an int variable, and we send in a double variable, and we send in a long variable. So this call to this no such function is a perfectly matching call. All the types match. But you can also do these widening conversions. So we can do the int var. We can pass an int var for all of these, even for the double and even for the long, because ints are smaller and they can be automatically converted into a double or into a long. So it's okay to pass smaller types in as parameters. And then for the result type, we can put the result, this is going to return a float, and we can put a float into something that we've defined as a double, because float is smaller and float can be automatically converted to the bigger type, the double. So this would also work. Even though these types don't exactly match, the conversion is a widening conversion here from the int to the double and the long, and the conversion of what this returns, a float, is a widening conversion to put it into a double result. In processing, we've been doing a lot of graphics calls like rect and line and ellipse and so on, and what you probably don't realize is that all of those calls to the drawing functions actually call for float parameters if you looked at the reference for processing. But because we've been using int, that works fine because int is a smaller type. And so every time we pass in ints to like the rect or the line or the ellipse function, they're actually getting automatically converted into floats for use inside of that function. Now, if we had a variable like int x equals 20 and we're passing that into a call to something like rect, that doesn't mean that our variable x has suddenly become a float. It just means that when the number that was in x was passed into the function, it was passed in as a float to be used in that function that way. So you can look at the reference menu in processing to see what the signatures are for all those graphics drawing functions, and you'll see that most of them take floats. But you can't give a drawing function like that a double. This is what it looks like if you try to do that. If you try to call rect with 0, 0, 25, those are all ints, and then 38.0d, a double, you'll see that you get this error. It says the rect function expects parameters like this. And it's not the ints that it's having problems with, it's only the double. All right, Sometimes you want to do a narrowing conversion. You want to take a bigger type and you want to force it into a smaller type. And this happens fairly frequently when we have something like a float or a double and we say, no, we really do need this to be an int because we need an int as the input to some function or what have you. And so doing a narrowing conversion is something you as a programmer have to explicitly say, yes, I want to do this. And it's called casting. And there's two ways to do this. One of them is processing specific, and this is to use built-in functions in processing. So float of x will take any number that you pass into it and make it into a float. And then int of x will take any number you pass into it and it'll turn it into an int. But you have to be really careful here. You have to know what you're doing if you're going to do this. Because if you take a number like 17.357 as x and you convert it to an int, that number is going to become 17. You lose the 0.357 part. And there's another way to do this, which is this is the Java casting way. And so here we take the type that we want it to become, we put that type name inside of brackets and put it in front of the thing that we want to convert. Okay, so we're going to look at an example in processing to see what this looks like. All right, so here's an example of float x equals square root. So we're calling a square root function and we're passing in a float. So that's what this takes. And we run this and it produces 5. And that's fine. But if we wanted x to be printed out as an int, then we could do something like this. We could do int of x and print that out. And we see now we only get 5, we don't get 5.0. Or we could do int like that of x and do the same thing. And again, we get 5. And I want to show you if we don't have the float, if instead we have something like float x equals 79.3567, there we go. And then we do the casting, you'll see that we only get the 79. We've lost all of those digits. Okay, so let's go back to the square root example because I want to show you what happens with functions if you don't pass in the right type. So the square root function takes a float as a parameter, but we can pass in an int and that will work just fine. It will still give us a float back, although we've done the casting, so we'll remove that here. So we're passing in an integer, but we're getting a float result because square root will always generate a float result. So we can pass in an integer, we can pass in a long, still works. We can pass in a float, still works, but we can't pass in a double. You see, this gives us an error because it can only take a float and a double is a bigger type. So that doesn't work here. Okay. And the other thing to pay attention to is the type that you're assigning to. So square root returns a float. So we could make this a double because double is bigger. And so we can take a float and put it into a double and that will be fine. Okay. But if we make this an int, this is not going to work. You see, this generates an error because square root returns a float and float is bigger and we can't squeeze a float result into an int variable. We could do this though if we do a cast. So if we do int of square root of 25, then this works and we see now we get 5. Okay. And if this was a number that was not something that gave an even square root, if we did something like 37, which is not an even square, you can see that we get this number. The square root of 37 is not 6, it's 6 point something. But because we've done the cast to int, we lost the precision. Okay, so hopefully that gives you a good sense of all the different type conversions and the idea of bigger types and smaller types. We can always automatically put smaller types into bigger types, But if we want to put a bigger type and squeeze it into a smaller type, we've got to do this casting, either the processing way or the Java way. And we have to be aware that if there are fractional parts when we convert to an int, we're going to lose those fractional parts. All right, that's all. Thanks for watching.